All right, so let's talk about how Earth's climate naturally changes. And there are 4 ways that we're going to look at today. So the first one is sunspots. Now sunspots are pretty easy. Basically, a sunspot is an area of intense solar activity. And sometimes the sun will have more sunspots and sometimes it will have less. So the solar radiation that the sun emits, it is influenced by these sunspots. Sometimes there will be more and sometimes there'll be less. So the amount of solar activity on the sun directly affects the amount of solar radiation Earth receives. So here we're going to see a classic, and we're going to need this word for pretty much all 4 of our causes, is a fluctuation, to go up and then to go down, okay? So that's pretty much sunspots. They can cause, or they can be linked to ice ages, for example, or medieval warm periods. But yeah, they're pretty simple, and actually it's often the one I would encourage kids to write about. The next 2 are very, very similar, okay? So we'll talk about volcanic activity first. So here's a volcano. And as we know, it spits out lava, but it also spits out a huge ash cloud. And it does so into Earth's atmosphere. Okay? So we have a huge ash cloud being pumped out into our atmosphere like so. Now what happens is not too dissimilar from the greenhouse effect in many ways, because some of that solar radiation will hit our ash cloud and it will be reflected. Yep, like so. So you can see how that would then cause Earth's temperature to go down. However, much of these ash clouds are greenhouse gases, and so like sulfur dioxide and carbon dioxide. So what we actually see is a short-term decrease in temperature, but actually a long-term increase. That's a fluctuation, isn't it? Okay? So, number 1, sunspots. Number 2, volcanic activity. The other thing that's very similar is asteroid collisions. So an asteroid is a large rock traveling through space. What it does is it impacts Earth, and same thing kind of happens. Huge ash cloud is released into the atmosphere. Again, this would be a lot of CO2 released. So again, it's classic greenhouse gases. And also a lot of solar radiation being reflected back into space, not being absorbed by Earth, not engaging with the greenhouse effect. And so again, Earth's temperature here will decrease simply because there's less solar radiation. You know, this is really what killed the dinosaurs, because the ash cloud was so large, it destabilized all of Earth's ecosystem because there wasn't enough photosynthesis taking place. Okay? However, in the long term, more greenhouse gases in our atmosphere means the temperature going up. That's a fluctuation. Now the last one is the Milankovitch cycle. I wouldn't touch this with a barge pole. I don't often touch things with barge poles, but I certainly wouldn't be touching this with a barge pole. Yep. But sometimes they do directly ask you about it, and there's nothing you can do. You have to talk about it, right? So the Milankovitch cycle, or orbital change, is just this idea that Earth has an orbit and its journey. And what happens is this journey oscillates. Oscillates means to kind of move from a circle to an oval in a repeated motion. It's oscillating all of the time. Eccentricity is the word that we kind of use. It kind of means it changes from circular to elliptical, affecting the distance from the sun. So this is kind of about distance, right? All of this is fancy words from saying sometimes Earth is closer to the sun and sometimes it's further away. Now you know if you stand close to something that's warm, you get heat temperature. If you stand further away, you have less temperature. So we see here that this is altering solar energy distribution. These changes in sunlight distribute across Earth, influencing global temperatures. Again, it's up and down, meaning this is a fluctuation. The Milankovitch cycle is definitely linked to ice ages as well. So if you're talking about effects as a result, this can lead to an ice age taking place. But yeah, these are the 4 ways in which Earth's climate naturally changes: sunspots, volcanic activity, asteroid collision, and orbital change, or the Milankovitch cycle. Okay? We're now going to jump into an exam question. I hope you found that useful.